Terrific. Well, thank you very much, and really excited to be with everyone here today. We're here to talk about technology-enabled cybersecurity assessments. Just by brief introduction, as described, I won't go through my background too much, but just a brief introduction of Verve. We've been in the OT business for almost 30 years now, helping clients secure and improve the reliability of their control systems. About 15 years ago, we developed the Verve Security Center, which helps our clients create an overall integrated perspective and improvement in their cybersecurity maturity. And then we provide a range of services such as assessments, et cetera. And what we're going to talk about today is built on that last 15 years of helping clients both assess as well as remediate the risks in their OT environments. So just briefly, what are we going to talk about today? So first, we're going to spend some time talking about the overall risks to OT, cybersecurity risks, and the potential impacts and what are some of the trends that we're seeing. We won't spend a lot of time on that, assuming most of the people on this call have a perspective of, they're here because they realize the risks, but we do want to set the stage a little bit. Then we're going to talk a little bit more in detail of what are the advantages of this concept of a tech-enabled assessment. And we'll talk about what it is and what the benefits are. And then we'll go through a little bit more detail of how this works and how it improves the efficiency, both of the assessment part, but also the remediation that is required once the risks are identified through the assessment. So as we think about the world of IIoT or OT or ICS, depending on what phraseology we want to use, cybersecurity, we have laid out this concept of air raid, a way to try and a simple mnemonic to try and remind ourselves of what's going on in the world of OT cybersecurity. First, on the attacker front, we are seeing a significant increase, not surprisingly from the press, of threats and attacks in OT, and the large driver of that is ransomware. It is the fact that commercial hackers have discovered that industrial environments are a very attractive place to focus from ransomware point of view. The second main theme or trend we're seeing is a much greater role of IT, both in cybersecurity, but more broadly even in the world of OT management. And so we're starting to see, obviously we've been talking about IT-OT convergence for a long time. However, we're starting to see over the last 3 or 4 years a significant increase in the organizational components of IT leadership being involved. Next is regulation. The recent announcements from the TSA are just one example of this, with both their pipeline announcement from probably 60 days ago or so, but also more recently, just in the last 2 weeks, about rail and aerospace. And that's just in the United States, but we're seeing this happen in Chile, where they've adopted the NERC-CIP standards directly, the Middle East with the DESC standards in Dubai, et cetera. Regulation of OT security is coming, and it's going to be much more prescriptive than it has been. The second R is resource constraints. This is a major driver of the risks growing in these environments as more and more resource constrained production facilities, in large part, partly due to COVID, but also just generally the trend towards leaner and leaner staffs is happening. Alert fatigue, we are seeing a tremendous amount of alerts, both in terms of threats as well as vulnerabilities. And that is causing significant burnout, as it were, from the SOC and other detection groups. Insurers are playing a much bigger role in this space now, and insurers are requiring more detail on how OT or ICS cybersecurity is performing, what sort of techniques operators are using to ensure that you can get that insurance. And then finally, obviously, directors becoming much more involved with cybersecurity more generally, but down into the production environments as well. And so these 7 things are we sort of come up with as a way to sort of simplify down what are the major trends and how is the world of OT cybersecurity evolving. Just some quick data. And manufacturing and energy are now the second and third most targeted industries, up from being 8th and 9th a year ago in 2019, or a year and a half ago. It'll be interesting to see what the 2021 data show. Our guess is that it will only increase. But industrial organizations are now truly in the crosshairs of the attackers. And while the press also, is talking a lot about ransomware, we've seen a lot of public ransomware attacks. This is now flowing across to the operators themselves. So what you see on this chart is the survey, the SANS survey from the last several years. And what you're looking at on the left-hand side here is what percentage of people say that the greatest threat vector is any of these at the bottom of the page. And ransomware has gone from, 4th or 5th on the list 2 years ago when this survey was done to clear number 1, and over 50% of people saying it is the number 1 concern that they have. Not surprisingly, right? This is the major threat. We are starting to see this huge growth in ransomware in the OT environments. And those same people are recognizing that these risks are more and more severe as they come. And not surprisingly, right? These are significant financial risks to a business, as well as obviously the reputational risks, et cetera, that would go along with ransomware and customers, et cetera. Not to mention, by the way, the other types of risk around safety, et cetera. But ransomware is really popping to the top of the list right now. And so this air raid concept or trends are driving a new set of questions. These questions are much more about demonstrating progress, demonstrating current status, demonstrating auditable results, et cetera, than they've been in the past. It's not just about now, okay, show me the threat detections. It's now getting down to show me where I was a week ago, a month ago, 6 months ago, and show me where I am today. And so the implications that we see on the requirements for OT cybersecurity are threefold. Number one, we're going to need to be able to demonstrate progress in reducing risk. Number two, we're going to need to move from those alerts that are now overwhelming folks to a more targeted, accelerated response to those threats through getting better telemetry into our detections, but also from being able to move from monitoring to response. And then third, increasing efficiency. We just don't have the resources to be able to do this. And so we're going to have to find a way to do it much more efficiently. And so as we have approached the assessment and the remediation of risks for our clients, we felt that there needed to be a different way of going about this. It had to address this idea of continuous risk reduction. It had to be able to get to a response plan. And then finally, it had to do it efficiently. We can't be just having people fly around to all the global facilities. We can't do it through each site or each vendor having their own security system. We've got to find a way to scale this. And so that's where the technology-enabled assessment came from. It came from these trends and challenges that we need to resolve for OT cybersecurity. So to start with, what are typically what we see when organizations go through their OT cybersecurity journey is there tends to be these three stages of it. The first is the organization will go out and assess the environment, right? And this is set against the NIST cybersecurity framework, but you could lay this out against other frameworks. But basically, there's an assessment phase, which includes gathering information about the inventory and the risks. It includes creating policies and procedures, starting to analyze log data, et cetera. Once that assessment is done, then there is the process of, okay, I need to start remediating these risks. I need to put in tools. I need to patch. I need to conduct network segmentation. I may need to harden configurations of devices. et cetera, a number of remediation tasks, training, et cetera. And then over time, once that sort of first level of remediation is done, then there's the maintain and improve phase of trying to continually monitor my asset risks, maintaining protection status, so continually updating patches and updating antivirus and whitelists and starting to detect threats and with real-time telemetry, et cetera. And so these are the three broad phases typically that we see organizations go through. And so what we want to do today is really focus down on that assess piece. So how do we get effective, efficient assessment, particularly in environments where we have complex network architectures, lots of embedded devices, can't use the traditional assessment tools that you might use in IT because of the risks and sensitivity of those devices. So how do we go about assessing? And so we have built what we call the tech-enabled assessment process. It includes three phases. The first phase is around aligning on whatever framework and objectives you have. What are you going to assess against? The second phase then goes in and does the technical assessment. And we're going to spend most of our time talking today about how that technical assessment can be done. And then phase three is once that assessment gathers the right level of data, how do we develop and prioritize a roadmap that we can then execute on? And in parallel to all of that, there's obviously a process of establishing governance and processes that would align against whatever remediation tasks we have to have. But whatever this assessment process is, we got to be able to go from the assessment to the remediation pretty quickly. We don't want to end up assessing things for a year and a half and then spending another 6 months planning and then another year and a half remediating. We need to move faster than that. And so this is what the tech-enabled assessment allows us to do. So the tech-enabled assessment starts with a platform, starts with a technology platform. And that technology platform begins at its core with a robust asset inventory. We can't do a real robust vulnerability assessment or risk assessment without understanding the asset inventory. We find many organizations, the alternative to this is often a survey-based approach, or with an organization that will be hired will go in and maybe do a walk down of the facility. Our view is we can't really know the risks until we get into that inventory. And so that's where it starts. And then that inventory allows us to build a set of, I'll call it applications on top of that information. Number one, vulnerability management. So what are the vulnerabilities? And the ability to do that without having to scan and potentially trip a plant in the process. The ability to gather patch information of missing patches, the risks to those, configuration information, user and accounts, right? So often dormant and accounts with misconfigured passwords, et cetera, are one of the largest risks that we see. Getting anti-malware status, starting to gather data around, are there intrusions ongoing in the environment? And then finally, do our incident response practices and technologies available, right? So for instance, are our backups up to date, et cetera. And that platform allows us to get what was referred to earlier as a 360-degree view of the risks in that environment. It brings together endpoint and network information and allows us to aggregate this across an enterprise, right? So instead of having 50 different assessments across all my manufacturing sites, I get one assessment that has the ability to break down along those 50 sites, but I can aggregate it and see it in one place. So that is the engine, I guess I'll refer to it, that allows us to drive the tech-enabled assessment approach. And we'll talk more about that engine as we go here. So what are the benefits of this? Broadly defined, there are 5 primary benefits. The first is, this is an approach built by control system engineers for control systems. As I mentioned, our company is about 30 years old. It was founded originally as a control system engineering company, right? So our team is based with people who have control systems backgrounds. And so this entire approach is designed in such a way that it's safe in the OT environment. You don't need to scan devices with traditional IT scanning tools, for instance, that may cause disruption. The second is better risk management. Because of gathering the level of data that you can through a tech-enabled assessment, you can identify risks across not just vulnerabilities, CVE scores, but all of the missing patches, all of the users and accounts that may be causing risk, AV status that's out of date, configuration statuses that are risky, et cetera. And that, instead of just doing one pen test, allows you to do, which is very risky in OT, it allows you to basically simulate all sorts of different penetrations that might happen and run those risk models. Number three, better enterprise visibility. This approach allows you to get that central visibility and scale the analysis back to the efficiency point again. Next, it accelerates the time to actual security maturity. So by having the tech-enabled platform in place, not only do you know the risk, not only can you assess, but the fact the platform is already deployed, it allows you to immediately move to remediation. So the platform goes from assessment to, okay, now I know what patches are missing. I can deploy patches right from that same platform. I can harden configurations. I can remove software that shouldn't be there, et cetera. And so it rapidly accelerates the time to remediating those risks. And then finally, because the platform is in place and giving you updates in real time, I don't have to wait another year to do an assessment. I'm literally assessing every day, every week, whatever it is. And as a result of that, I can, back to the air raid point around directors and insurers and regulators wanting to see progress, I can show them progress on a real-time basis of I was red yesterday and I'm green today. And so broadly, these are the 5 key benefits that we see from this tech-enabled approach. So, okay, if those are the benefits, how does it work? So now we'll dive into a little bit of the details. So I mentioned before this 3-phased approach. The first is aligning on the framework and objectives, and we're going to talk a little bit more in that. And basically what's included in here is developing a straw man framework and then running workshops with the team to review different alternatives and create a framework that works best for that organization. So what framework do we start with? We're not here to try to push one security framework versus another. The tech-enabled approach works on pretty much any standard that you'd like to. These are results from the SANS ICS security survey, that same survey I mentioned before. And what you can see from this is when OT or ICS organizations are surveyed, the NIST cybersecurity framework becomes the leading or dominant or whatever you want to call it framework that people have adopted. But that doesn't mean there's not other ones being adopted. As you can see, for instance, IEC 62443 is gaining, a little more traction each year. And a lot of organizations we see combining these, right? So they'll take components of IEC or ISA 62443 and integrate that with NIST cybersecurity framework. We're not trying to tell you this is the one to use or not. The point is understanding the different options you have and selecting something. It is really, our view is very, very critical that before you get going on your journey, you pick some framework, standard, direction that you're trying to get to, and you get clear on that as a leadership team so that you can A, assess against it, and then B, measure against it as time goes on. So if we start with that NIST cybersecurity framework option, again, not the only one, but just to use it as an example, these are the core elements of identify, protect, detect, respond, and recover. And so what the process is to go through these elements and understand, okay, how are we going to look at all of the endpoints and the network that we've got, the networks that we have, and identify these risks. And so that starts with that 360-degree view of risk, which is the identify piece. And then it looks at how protected are we? Are we doing things like patching? Are we doing things like hardening configurations, et cetera? How does, are we actually detecting potential threats? Do we have comprehensive telemetry? Are we looking at things other than just network flows, for instance? Can we respond quickly? And how able are we to know when a threat is going on, what we can do to respond to it? And then finally, do we have robust, up-to-date, timely backups? Can we recover quickly? And so this would be a typical framework that we work with our clients, and obviously there would be much more detail behind this, but at least at a high level, you get the sense of, ensuring that we have that framework we can assess against. So once that framework is set, then the next step is, okay, let's go technically assess site by site risks against that framework and model different types of penetrations that might exist to understand the real risk in that environment. And so when we step back, okay, what does that look like? What do we want to look at from a risk assessment point of view? Again, lots of models one can use. This is the defense in depth model of the Department of Homeland Security as one example framework. But it's helpful to lay out, okay, where are the levels of risk that we want to look at? We don't just want to look at endpoint, right? We don't just want to understand the CVE scores on these devices, but we want to start at the top, right? Okay, what policies are in place? What are my different network protections, both at the perimeter and at the ICS network level? How good are my access controls? And then finally, obviously, what's going on at the host level and the endpoint level? And each of those has different elements, as you can see, and we'll make this presentation available. But to give you an example, endpoint isn't just about CVEs, right? It also includes those other topics like what are our malware protections? Do we have software that we just don't need to be on the system? The number of times we go in and discover CD burners and iTunes and log me in and other things on ICS systems is amazing. You know, on the access control side, right, are privileged policies in place? Do we have the right remote access going on, secure remote access, or do we have insecurities in remote access, et cetera? So that's the, I guess, the framework we're going to try and fill out. So we begin with policies and procedures. And so again, this is just an example, but basically what we try to look at is we look at those policies and procedures and we try to look and say, okay, how adequate are those from an IT setting? How appropriate are those IT policies in OT? And then how well have they been implemented? And those different frames allow us to get a sense of how mature from a policy and procedure point of view the OT organization is overall. Obviously, this is done through reviews of documents. This is less tech-enabled, so to speak. It's done through review of documents, et cetera. But we believe it's important to have that procedural policy look as well. But then as we get in to the technology-enabled front, we then start with, okay, let's look at that inventory, as I mentioned before, right? So we got to understand, okay, what are all the manufacturers? What are those subclasses? We want to look at what are the different characteristics of lifecycle management that we're taking. So how old are the, oops, I think how old are the operational systems? How old are the OSs? And then what we do is we'll create different impact categories. So is this a critical device to operations or not? And then finally creating a lifestyle risk score. So how at risk is this once we add up all of the different risks of that asset? And we'll talk about what goes into those calculated risks. So that's the first piece, is let's get that detailed asset inventory. That includes, as I mentioned before, getting down to all of the software on the system. So a lot of times people will take some samples, right? They'll go and ask for sample data from certain devices. What we often find is that misses a tremendous amount of the risks from this installed software that frankly nobody's really using. You would never see it if you captured packets on the wire, right? It's not being used, but it creates insecurities in the environment that are just not necessary, that we could maybe go down and remove over time. We obviously then want to get vulnerabilities as well. We want to look at, okay, what are the CVEs on these assets and how risky are they? And so the tech-enabled assessment, the approach this uses is it gathers all this data on the inventory without having to scan it with a vulnerability scanner, et cetera, but by gathering all that software data, gathering all the patch data, gathering all of the version numbers, et cetera, what we can do is we can provide a vulnerability assessment without having to scan. And that capability then allows you to demonstrate things like this and see within that environment, okay, how many critical vulnerabilities, how many high vulnerabilities, what are the different impacts of availability, integrity, et cetera. And then I can start to say, okay, how do I prioritize them? Are they recent? Are they old? Are they exploitable or not? And then can I address these, or am I addressing these through some form of a compensating control, or do I really just need to patch it? And importantly in OT, as we all know, this vulnerability assessment can't just be on a bunch of Windows boxes, right? This has to get all the way down, as this example at the bottom does, of getting all the way down to the PLCs and the cards in the PLCs, so that you can see the risks, not just in the OSs, but also down at the firmware level. Again, that risk also includes not just vulnerabilities, but also missing patches. And one of the keys to being able to resolve these risks going forward is knowing exactly what patches that we're missing, how old they are, what vulnerabilities they address, et cetera. And so by doing the tech-enabled approach, I can get to literally every single asset and what specific patches are missing on that asset. The level of granularity around risk explodes because I have this patch, this asset level view of things like patch status. Similarly, configurations. One of the riskiest things in these environments is that they're often not managed through some form of central Active Directory. And one of the implications of that is domain policies, et cetera, group policies are not necessarily set, or certainly not well managed. And so one of the things the technology platform allows you to do is to check against things like DISA STIG or CIS or other standards to know how secure is the system. Am I set up for security? And if not, what are those specific risks, the bad, and then what am I doing well on, right? And what we've done is we've tuned these compliance checks to be specifically relevant within the OT environment, so that we're not ending up having to scan these devices, which could possibly cause disruption to them. So again, that tech-enabled assessment is gathering that detailed information about, for instance, configurations. Similarly to that, because many of these devices aren't managed in detailed ways, we have user risks. So we always find some level of accounts with expired passwords. We've got tons of different administrator accounts on hosts. A lot of times this happens because OEM vendors may come in, or partners may come in to do work on the system, and they create an account, and then they leave that account, and it's never cleaned up. And so when you do the assessment, you discover dozens and dozens and dozens of these dormant accounts, or accounts that aren't well managed in terms of passwords, et cetera. And you could patch everything, but if you've got these risky user accounts out there, it's a tremendous risk. And then finally, the tech-enabled assessment allows us to look at network risks as well. So, are the networks flat? Are we seeing traffic move between IT and OT? Are we seeing, even within a DMZ, are we seeing sub-segmentation? Risk number 4, do we have dual-homed devices? A lot of times we'll see this, sometimes by design, sometimes because there is a firewall put in place and an operator needs remote access, and instead of working through the firewall rules, they create a dual-homed server that goes around the firewall, as an example. And by having the technology in place, you can see these things, right? You look at the network diagram, and the network diagram looks wonderful, but it's, as one of my colleagues says, it's the rot that happens over time that you don't know about, nobody documents. And the network configurations get out of whack, or the dual NIC gets put in, or whatever it happens to be. And by having the tech-enabled approach, you can actually see that. You can see the traffic, you can see the number of NICs in a device, et cetera. And that allows us to get down into the weeds of the network risks. And so at the end then, what we come back and say is, all right, given that view, that tech-enabled view, I can then start to prioritize the risks, both those policy things that we talked about at the beginning, but also each of the elements of these risks. And I can start to say, all right, where are the biggest ones of these risks, right? Which are the ones that are going to cause potentially the greatest threats? And so what this allows us to do is essentially aggregate those tech-enabled views into a more higher level view so that organizations can get their heads around what they could possibly do about this. So I've now gone through the technology-enabled assessment. I mean, I've gathered all the risks. I've got all this view of the risks. But at this point, I don't have a roadmap yet. I just know that I got a lot of risks, and I can start to prioritize those risks. But I'm not yet to what do I go do? And so the next phase of the approach then takes that and uses the technology to help us build a roadmap. So the first thing we do is, as I mentioned before, we need to create options, or better phrase, scenarios of how threats may move through an environment. And a lot of times, particularly we'll see RFPs for an assessment and it will say, includes a pen test. Well, for those of you in this world, pen tests are quite risky if you do them in a significant way in an OT environment. So then the pen test always ends up being kind of partial and maybe not on the real system, et cetera, et cetera. And so what the technology-enabled approach allows you to do is allows us to model all sorts of different potential penetrations. Because we have that detailed information on each asset and each network in the environment, I can now model things and I can say, okay, what's a possible threat? Let's take ransomware. All right, so what are the vulnerability vectors that it may come through? Well, it comes through on weak firewalls, lack of patches, AD infections, et cetera. Okay, so what's the operational impact of that it locks up an HMI or something? What can I do about it? And then how long would it take me to recover? Okay, I can then lay that out and I can start to model out different scenarios of how that could happen, which then allow me to say, all right, which of these are the most likely and greatest risks based on those different modelings that I can do, again, because I have that data available to me. And then what we can do with that is say, okay, given those risks, given the potential cost or outage timing or whatever it happens to be, I can then take that and turn that into a set of initiatives of things that I can do in the near term, middle, and then longer term, right? And so again, this is not meant to be, this is the answer for everybody by any means. This is just an example kind of structure of where we'll look across those different elements of security from endpoint to access control, network, and procedure. We'll say, okay, what can we do in the beginning? Well, we got a lot of current capabilities, right? We already have this, the tech-enabled platform in place, right? So if I've got Verve in place, what can I do? I can start patching. I can start hardening configs. I can make sure that the backups are up to date, and if they're not, I can maintain those and monitor those. I can get rid of that risky software like TeamViewer that I found, et cetera. I can start to implement password policies at the access control layer, and I can enforce those by enforcing new configurations at the endpoint. And then on the network side, I can go in and I can remove those dual NIC devices and make sure things are going through the firewall. I can tighten the firewall rules, because one of the things that we're pulling back is all of the firewall rules, right? We know every rule in the environment, and so we can start to say, okay, we need to harden here, et cetera. So there's a set of things I can do right out of the box because I've got this tech-enabled platform there, no new investments, et cetera. But then there's some things that, okay, now I really do need to start making some additional investments, and that could be in things like training or on the human side. It may require segmentation, and that may include additional hardware. We start to monitor for indicators of threats, and then finally employing endpoint type protection like application whitelisting, updating AV signatures, et cetera. And then finally, over time, adding in more advanced or the next generation of security. Now, obviously, some folks are already at maturity level 3, and so this would start at a different point. But the concept here is to be able to have those insights that come from having that technology enabled, to be able to prioritize these different risks based on, as I said, the modeling of the different threats. And then obviously, because you've got the platform in place taking those actions. And that's the point, right? So what the tech-enabled approach allows you to do is build this 360-degree risk assessment, the vulnerabilities, the patches, the configs, et cetera, and to create a risk score. So every asset gets a risk score in this model. And that risk score takes into account these different components. But it's not enough just to know and just to assess. What the Verve tech-enabled platform allows you to then do is immediately go to fixing it. Right, so because that platform's in place, I can take actions, I can patch things, I can harden configurations, I can remove users that shouldn't be there. Obviously, all done within the coordination from the ICS engineers involved in that operation, whether it be at a plant or in that pipeline network or whatever it happens to be. But the fact that the technology is there, ready to go. Rapid both accelerates the move to remediation as well as driving more efficiency in the labor processes of that. One of the other advantages of having a tech-enabled solution is that I can move from a one-time detection or a one-time, assessment, and I can start to monitor this literally minute by minute, day by day. Insurers, regulators, directors, they're all starting to ask, what have you done for me lately, right? Okay, where are you today? And I want to see over the next quarter, or 2 quarters, or whatever it is, how you're making progress. And so by having that tech-enabled platform in place, we can start to show red and green, and we can start to show how that is improving over time. How are my pie charts getting better over time? Or how am I moving more of these CSC 20 bars from red to green? And that tech-enabled platform allows you to do it without having to send another team out, do more surveys, et cetera. So finally then, okay, I've now got the assessment, I've got the roadmap, and I'm starting to implement. But the only way I can really do that is with the right governance and processes in place. And this is not intended to be a long governance and process discussion. But one of the keys to this approach is that as that tech-enabled assessment is being done, we are in parallel ensuring that the governance is in place to be able to maintain that system and also continue to improve the remediation of the various risks that are identified. And so the way we think about that is what we call think global and act local. And so the tech-enabled platform, as I mentioned before, allows you to consolidate globally. And so what we're doing with this is we'll take data from, we got clients, 600,000, whatever it is, locations all over the world. All that gets aggregated up into one global platform. And so I can see my risks in one place. I can start to prioritize those risks. I can build playbooks for remediation, one place centrally. And then I can start to work through that system over time to act locally. Some organizations, if they're global, will have a regional subject matter expert involved in this governance, just because logistically, sometimes you have to go on site and having somebody in the region makes sense. But when we want to go take those remediating actions, that tech-enabled platform is designed so that we can, as I said, scale everything centrally. I can see it centrally, but the actions then happen locally. And so I can design a playbook and distribute that to the local experts, the local sites for the experts to be able to look at for that particular process. But when I'm going to patch or when I'm going to harden a config or whatever, the person that pulls that trigger, so to speak, is the person who knows the process. In many cases, this is the on-site control system engineer, because we don't want to be patching from 2,000 miles away and possibly trip a coal plant or something in the process. And so being able to have that local control over that final action. So it's all automated, but that before the action happens, there's someone who understands the process, knows if it can happen at this time, when the outage is, et cetera, when that action can take place. And so this governance model that we've designed here is what we, as I mentioned, is what we call think global and act local. And that governance model then ties back to the tech-enabled approach that allows us to sort of take advantage of that technology. But at the end of the day, that what matters, right? What matters is success. What matters is the ability to do this tech-enabled assessment, understand that initial score. So in this case, this was against the NIST cybersecurity framework, where we had the client evaluated themselves against all the various components of NIST. And then once we went through the assessment and once we went through the remediation, then remodeled that. And over about a year's period of time, got about a 2x improvement on those scores. In large part with the efficiency of doing that without adding a ton of headcount, because they could again scale that governance up to the top, scale the analytics, and then distribute those actions for local actions. So hopefully that was a helpful walkthrough. I know there's a bunch of questions. I've seen the little comment or question chart pop up here several times. And so with that, I think I'll turn over to questions, if there are any. So I'm just gonna.
Excellent. Well, thank you, John.
Absolutely, Renee.
Thank you, John. That was an excellent presentation, and we do have some questions, but I will remind our audience members that and still continue to submit questions here. Use that control panel at the right to just submit your questions, and we'll get to as many as we can in the next couple of minutes. So a first one for you, John. You had mentioned and emphasized that there are multiple cybersecurity frameworks and that Verve works with all of them. The question I had was, does Verve offer any support for people trying to choose one? Or are there ways to evaluate what frameworks we should be starting with?
Yes, we do. Obviously, we've got a lot of experience with different ones, and so we walk in with a bit of a bias, having used a lot of the different frameworks. So we have, I guess, an incoming view of which ones are effective. But a lot of this comes down to working with the client and what their environment is and how best, what solution will work best for them. So let me give you an example. One of our clients is was really driving this from the IT side. And they had set up the standard of the CSC 20, or it's now called the CIS Top 18, I believe. And they were using that on their IT side. And so as we talked about what's the best standard for them, they really wanted to have consistency from a managerial point of view across IT and OT. And so what we did with them is we helped them shape that CSC 20 or CIS 18 standard to OT. And that meant we had to go through a number of those controls and say, okay, out of the 170, there's probably 30 or 40 of them that just can't be applied into OT for whatever set of reasons. As an example, antivirus. You can't really put antivirus on a PLC. So we created a set of technical exceptions with them, and then a process for reviewing those technical exceptions, so that as you went through this process, you had clarity in the organization about what would be qualified as a technical exception. And that approach was great for them because that was a model they used. We've had others where they've combined NIST cybersecurity framework with the IEC 62443, which gives us a great overall framework with NIST, and then very specific suggestions, recommendations, standards around zones and conduits, et cetera. And so, yeah, we have some incoming ideas, but we always work with the organization around what will work best for their particular starting point and their objectives.
Got it. That makes a lot of sense. Thank you. Another question, just about the getting started. Clearly, this is a more comprehensive approach than some of the others in the OT security space. How long does it take to get set up and started and get to something that is useful?
Yeah, so this is frankly one of the benefits of this approach is it can be done much more quickly at scale than the more traditional survey-based approach or visits. So a lot of times what we see is organizations where they're having assessors fly out to their sites and interview people and try and walk down the environment, et cetera, or they're waiting for results to come back from the survey, which oftentimes lead to nothing because the people don't know the answer. When the people who they send the survey to don't actually know the answers. And so most of the time, this is a faster approach than that because we can deploy the solution very, very quickly. Usually, it all depends on the size of the environment, but it's somewhere between a day and a week or so to get the solution deployed. And we can do that all remotely. Or we don't have to go on site to deploy that technology. And as a result of that, we can do sites all over the world very quickly without having to fly people all over the world to do it. And so, typical process from beginning to end would be if you were doing, one facility might be, 6 weeks or so, from all the way from, beginning and starting to design the standards all the way through to making recommendations. However, if you're going to do an organization of 100 plants all over the world, likely that's going to be, you do that over the course of 6 months or 9 months or a year as you deploy the solutions and then frankly design the right roadmaps for each of those particular sites. But to do one is probably 6 weeks or so.
Much. Another difference in your approach seems to be this continual idea of assessing, monitoring, as well as then addressing the issues that you find. What kind of assessment tends to be that, in my mind anyway, that one time or that first time I look at it and then I decide what to do about it and then I do it. Well, when do I look at it again? So what kind of frequency or in terms of assessing regularly? You talked about the possibility of assessing every day. Is that something realistic?
It absolutely is. So the fact that the technology is there, it is giving you an update on your risk view literally in real time. I mean, it's probably every 15 minutes that it gets updated or thereabouts, but you can set it for faster than that if you want to. And so
Gotcha.
You're constantly able to see where I am. So as an example, you can say, all right, well, I went out on Sunday afternoon when the plant was down and I patched all this stuff. Great. Literally that afternoon, you'll see how you've gone from red to green on patch status and your risk score has improved. And so, yes, it's literally in real time.
Gotcha. All right, thank you. Another question that we have is the idea of how much of these framework standards apply if OT is 100% air-gapped from IT and the internet.
Air gap, what a wonderful phrase.
I know.
So we have yet to find anyone that is truly air gapped. Now, I will say we have several clients who use data diodes, and you say, okay, that's air gapped. That's, I guess you can just say there's absolutely no connectivity. But inevitably, what we find is even in a diode environment, I got to bring USB sticks in and out, for instance. Or, we find many organizations where they say they're air gapped, but when you actually get in and you look at this tech-enabled data, you see, oh, wait a minute, if you're air gapped, what is this connection coming in here? Oh, well, that's the vendor. He just comes in once in a while to do work on that system, right? So how is that air gapped? Or, I noticed that this new MAC address shows up every 3 weeks. Oh, that's the vendor because he's coming in and bringing his computer in. All right, well, you've just blown the air gap. So look, if somebody is truly air gapped, like there is a wall, there's nothing that can come through, okay, we could have a discussion around, how relevant, frankly, OT cybersecurity is in that world. However, the minute you've opened up to a USB stick or a transient cyber asset laptop, whatever, you've opened that network up to possible ransomware and everything else. And so in those environments, I think there's a phrase for it. It's called the M&M security, right? Crunchy on the outside, soft in the middle. Even if you have the crunchy outside, almost every time the inside is soft and squishy, meaning we're not patched, we've got shared accounts, we don't have hardened configurations, our software is not managed, et cetera. And as a result, the minute something gets through that exterior, through a USB stick or whatever, it can spread like wildfire. And so even in those air-gapped, quote unquote, environments, we would strongly argue that this is highly relevant. Hope that helps.
Understood. Yep, thank you very much. A question from an audience member. In Verve's scan of software and assessing an SBOM, are you able to get to a sub-application level, for example, API calls?
So to be transparent, Verve is not doing SBOM. We're not tearing down SBOMs within Verve. We do have a partnership, however, with a company called Adolis. Adolis does exactly that. They are tearing down SBOMs all the time. And so what we will do is we'll take their data from devices that, or frankly, firmware that they've identified to be vulnerable, and we'll integrate that into the vulnerability assessment. So basically you say, okay, I've got a Rockwell firmware version XYZ. We will be able to see, okay, that firmware includes the following subcomponents because we know that through our partnership with Adolis, and therefore it has these vulnerabilities that you may not know about, as an example. So we can do that. We are not, to be transparent, we are not doing that SBOM analysis ourselves, so we partner for that.
Gotcha. Okay, thank you very much. Next question is, what do you have to say, or how do you consider hybrid industrial environments, such as hospitals, laboratories, or any building with a connected industrial HVAC equipment, and how the operational systems might interact with the building management systems?
Yeah, so we think about all of those as quote unquote OT, meaning maybe a better way of phrasing this is cyber physical system. I think that's what Gartner is starting to call it now. And that's not a bad phrase, right? So these are systems that control physical processes. And so Verve would focus on all of that. Typically, just to be clear, we are more focused on, we don't do healthcare equipment, right? So we're not going to monitor an MRI machine, just to be transparent. Ours is on industrial and building controls and those types of things. So BMS systems, et cetera. And in fact, many industrial environments have those BMS systems. Security control systems like swipe cards and security cameras and that kind of stuff. So all of that, in our view, is part of this. Frankly, you know, if you talk to me in a year, we'll probably be doing the medical devices as well. We just haven't gotten there yet.
Gotcha. Let me see what else. We've just got a few minutes more here. What are the minimum network or system maturity requirements for this solution? A more mature segmented environment with management versus a large, flat, unmanaged network?
It doesn't matter to us. The solution works perfectly fine in either one of those environments. I would say what it does is it identifies the flatness that you may not have thought was there. So anyway, from a deployment point of view, we work in many sub-segmented environments, and then we have clients who are completely flat. In either approach works fine, and it doesn't really take that much longer in a segmented network than it would in a flat network.
Okay.
In fact, one of the things that it does is oftentimes people are they'll do an initial view through a traditional paper assessment. They'll say, okay, the first thing they got to do is segment, which there's nothing wrong with segmentation. It's actually very important. But what happens then is you say, okay, how are you going to segment? So what's communicating with what today? What has to communicate? What devices are even out there to segment? And then immediately you need to put something like this in so you can get that visibility before you segment, because otherwise you're just putting firewalls in without not really knowing, you know, what's going to be communicating and why it should communicate and whether you got all the traffic, et cetera. And so by putting a tech-enabled assessment in, it really allows you to set up that segmentation strategy in a more productive fashion.
Gotcha. One more before we run out of time here. Regarding the remediation steps, does Verve offer ways to do the remediation? The specific question was about ways to prevent the download of the extra software that you might have detected during the assessment phase.
Yes, absolutely. So we include a variety of out-of-the-box components for protection in Verve itself. And then one of the advantages of having that in is many of our clients want to deploy, let's say, application whitelisting to do exactly what's being referred to there, of stopping additional software from running. And because you've got the platform in place, you can immediately deploy that solution without any complexity. Like literally it's done in a second, because the platform can quickly deploy that whitelisting and lock it down. And so while, for instance, we don't sell quote unquote application whitelisting as part of Verve, we have partnerships with a whole bunch of application whitelisting vendors. And once Verve is in place, you can immediately deploy it and manage it much more efficiently. So yeah, it's one of the usual, almost immediate first steps that we often recommend.